So in this problem, we have a hydraulic jack, and we are told that we can put a pressure maximum of 16.3 atmospheres of pressure. So as hard as you can push on the one side, the input piston, okay? What's the largest mass of which we can raise? That's basically what it's asking here. Okay, so if I put 16.3 atmospheres of pressure, what is the maximum mass that I can lift? Okay, and we're told that the diameter of the output piston is 23.5 centimeters. Okay, so using this knowledge, how do we find the largest mass? Well, it takes a little bit of knowledge of our formulas. We need to know that through a jack, pressure is conserved, so the initial pressure on one side is equal to the final pressure on another side. So when I push on this, an equal pressure gets put onto that jack, right? The difference, of course, comes in, you can't just put 16.3 atmospheres onto this one and expect this one to rise the same amount, because it is actually a ratio. We know pressure is equal to force over area, right? So if I have a very small area, I can put a lot more force in, or I can put an amount of force and have a higher pressure. But if I increase that area, suddenly that pressure goes down, right? So I could put 16.3 atmospheres down, but what's the area, right? That's why this factor here is important, because, and we'll call this side A, and we'll call this side B, right? So we'll call this A sub A, F of A equals F of B over A of B. Now we can make a simplification here. We know that on the side A, we have a maximum pressure of 16.3 atmospheres. So we don't need to know the ratio between the force and the area. This can just drop out here and we can substitute it with the 16.3 atmospheres, right? But before we do that, let's actually convert the 16.3 atmospheres to newtons over square meters, because force is in newtons, area is in meters squared, and you're going to need to be able to cancel some units. Atmospheres just can't do that. So 16.3 atmospheres, for every 1 atmosphere you have 1.013 times 10 to the 5th Newton over square meters. Okay, and that's going to give us our output here. So 16.3 times 1.013 times 10 to the 5th, we get that we have a pressure of a very large number, 1,651,190 pascals. Okay, and we'll keep it in pascals here. And we'll actually put it in scientific notation, 1.65 times 10 to the 6. And that would be in newtons per square meters. Okay, so now we need to calculate one of these. And we can actually expand this more to get the mass. We know that for force, it equals mass times acceleration. So, right, we can say, okay, the force is, really just the mass times the acceleration. All right, and if we know that this is a piston, we know pistons are cylindrical, okay? Like that. And we know that for the area of this, it's just a circle. And we know that the area of a circle is equal to pi r squared. So we can put this to pi r squared. Okay, so we have a really good formula now. And let's even change acceleration to gravity, right? Because that's the acceleration of this body, right? Is due down with acceleration due to gravity. So we have our equation set up. Now we just need to plug in here. Notice our units are in 26.5 centimeters for the diameter. We're asked for the radius. We know that diameter would be like that, but half of that's the radius, right? So we're asked to find the radius. We'll split this in half. So let's actually do some changing here. The radius is equal to half of 26.5, and that would be 13.25 centimeters. Okay, and we need to convert that to meters. So we need to divide by 100 to give us 0.133 meters for the radius. So we have now our radius, we know gravity, so we can solve for mass. So let's let's actually put this over here. And I'll plug in everything at once. So 1.65 times 10 to the 6 newtons over square meters is equal to mass, that's unknown, 9.81 meters a second, okay? And that's going to be all over pi r squared. So pi radius 1.133 and square that. So, whew, a lot of math. So let's just do some simplification of bringing things over and dividing, right? So just some simple algebra here. So we multiply this by, oh, calculator, come on here. Okay, we multiply this by pi r squared. Okay, and then we're going to divide by 9.81. So we got a mass equal to 9,347 kilograms, all right? So given that the maximum pressure we can exert is 16.3 meters, doing some calculations with the conservation of pressure in a hydraulic jack, we found that the maximum mass that we can lift on a hydraulic jack is 9,347 kilograms. I hope you enjoyed this video. If you did, make sure to check out some of my other videos. I have a couple other examples of a hydraulic jack on my channel. Stay curious, stay awesome, have a wonderful day.